Hello everybody, this video is on simplifying square roots or radicals. In this video we are going to focus on the perfect squares method. We did another video where we did prime factorization, so this video is not prime factorization, it'll be perfect squares. So just a different way to solve the same problems. The prerequisite skills for this method is you need to know or be able to get perfect square numbers, and I'll show you what those are and how to get them. And then also we need to be able to identify if a number is a factor of another number, but we'll do some examples here. So I'm going to show you the perfect square numbers up to 529. They keep going forever, but for this video we're going to need up to 529. And I'm going to start writing them, but I'll show you how I'm getting these. So I'll do up to about 144 maybe to start. So the first perfect square number that we are going to consider is going to be 1. The next perfect square number is 4, then 9, 16, 25, 36. I'll reveal in a moment how I'm getting these if you don't know these. 49, 64, 81, 100, 121, 144. I'm going to pause there. I am going to go up to 529, but I'm going to reveal to you how I'm getting these numbers. So this would be, know these numbers or be able to get these numbers. That's one of the prerequisites. So how am I getting these numbers? Well, we call them square numbers because all I'm doing is I'm squaring algebraically, not the shape of a square, but algebraically, I'm squaring. So to get 1, I did 1 squared, 1 to the second power, which is 1 times 1. And that's 1. To get 4, I took the next number, 2, and I squared that. 2 times 2 is 4. To get 9, I did 3 squared. To get 16, I did 4 squared. And then 5 squared. 5 times 5 is 25. 6 squared. 6 times 6 is 36, etc. So up 144, we'll just put dot, dot, dot here. 144 is 12 squared. Now again, for this video, I'm going to do up to 529 because we'll need it, at least the way that I use this strategy. But I would say in most cases, at least for my class currently, if you go up to 144, you should be okay. So I'm going to write out up to 529. Okay, so there's all the perfect square numbers up to 529, which, by the way, if you want to count through it, this is 23 squared, 23 times 23. So right now, if you're wondering, like, why do we care about these numbers with the square roots? If you're not sure, we'll see that in a moment, so just trust me on that for now. But let's take a look at some examples. I'm going to do the same examples as the prime factorization method video. So our first example is to simplify the square root of 45. Now, remember, typically we want exact answers, so it is a good idea to try on a calculator, and we did this in the other video, but if I try the square root of 45 on the calculator, I get 6.708. It keeps going. I'm not worried about rounding here, but just to say, well, this is an estimate. Excuse me. The square root of 45 as an estimate is on the calculator 6.708. I know it keeps going. I'm not worried about rounding. Just when I get my final exact answer, we're going to check it against 6.708. So here's how the perfect squares method works. What I want to do is I want to take 45 and I want to find it to be one of these perfect square numbers times any whole number. So I want a perfect square number times some whole number. This is the overall goal here, and we could change the 45. It's not, the 45 is not special here, but this is the method. So I look at my list of perfect squares, and now comes the other prerequisite scale to say, how can I tell is 400 a factor? Can I do 400 times a whole number to get 45? That's called finding if it's a factor. Well, here's the trick. First of all, we don't have to check numbers that are bigger than 45. So I don't have to check like 400. No, because 400 times 0 is 0. 400 times 1 is 400. We've skipped over 45. So I only have to check the numbers that are less than or equal to 45, which means I can start, 49 is too big. I can start my search, at 36. So if I want to say to myself, all right, 45, can that be 36 times some number? And we're going to get a shortcut for this, by the way, if you keep watching. So maybe I say the whole number is x. And if I know my algebra skills, I can divide by 36. And I know that 45 divided by 36 is going to give us a decimal. So 45 divided by 36, 1.25. It's a nice decimal, but it's a decimal. So I go, no, I want a whole number. All right, so 36 is out. It's not 36. All right, well, what else could I try? Let's work down the list. So 25 would be the next one. Can 45 be 25 times some whole number? Well, let's solve that by dividing by 25. See if it's x is a whole number. Well, I know that 45 divided by 25 is, again, a decimal. Again, it's a nice decimal, but it's still a decimal. We're not messing with decimals. Okay, so it's not 25. So let's keep working down the list. Now, you might know already what the number is, but I want to encourage you to try to find the biggest number. So some situations will have an example where it's like, hey, I know this number that works. It's like, but is it the biggest? So 16 isn't going to work. And if you notice the shortcut here, we're just taking our 45 and we're dividing by these perfect squares. We did 45 divided by 36. We did 45 divided by 25. Now we're going to do 45 divided by 16. And our goal is to get a whole number. This is still going to give me a decimal. It's not a bad decimal, but it's a decimal. I'm looking for whole numbers. So, okay, but I keep working down the list. So now I'm on to 9. And if you've got your number sense, if you know your math facts, you already know it's 9. 9 is going to work. But just in case you didn't, 45 is 9 times some number. We're wondering if it's 9 times a whole number. Well, we can solve that by dividing by 9. And again, use the calculator if you need to, but I know 45 divided by 9 is exactly 5. It's a whole number. So I go, all right, that's my winner. That's my winning number. So we had that whole process. All right, so now I'm going to write it this way. I'm going to say 45 is 9 times 5. All right, keep in mind though, so I found a perfect square, but keep in mind we're really doing the square root. So if I say, well, then the square root of 45 would be the square root of 9 times 5. Okay. Now here's the trick. Here's the reason. You'll see a couple things why we care about these perfect squares. Some people might say, well, 45 is 3 times 15. Why didn't we bother with 3 times 15? You'll see here in a moment. So we're going to use a property of square roots. I have it at the bottom. If you want to say it in English, you could say it as the square root of a product is the product of square roots. Product is multiplication. So the square root of something being multiplied, two numbers being multiplied, is the same as multiplying two square roots. And then I wrote it out with algebra. The square root of a times b in the parentheses, or excuse me, inside the square root rather, square root of a times b in one square root is the same as a and b getting their own square roots individually, but keeping the multiplication between them. So this is why we cared about perfect squares, because what we can do now is we can say, hey, you broke 45 down to 9 times 5, and you're doing the square root. Well, then you can give the 9 and the 5 each their own square root. Now, this is why we care about perfect squares, because if you do the square root of 9 on the calculator, or you might know it, but if you take the square root of 9, it's exactly 3. Whereas like the square root of 5 is not a nice number. We already did the square root of 45, but the square root of 9 is exactly 3. And this is what we mean by simplifying. So we would have 3. Now the square root of 5 doesn't simplify, so we're just going to leave that there. But that's our answer. The only other thing we might want to do is to say, all right, well, let's remember how we estimated at the beginning, square root of 45 was 6.708. Well, let's estimate 3 times the square root of 5. So 3 times 5 square root is equal to 6.708. Hey, looks like a winner there, okay? So I'll try to go more quickly through more examples here, but let's do another example. Okay, so our next example is to simplify the square root of 126. Now, I've already gone ahead and done some things here. So one, I punched it into the calculator just to get an estimate. Square root of 126 is 11.224, whatever. Again, I'm not rounding here. I'm just writing down a few digits. But if I'm using this perfect squares method, I'm trying to find 126 is some perfect square times a whole number. And I've got my list of perfect squares here. So I can start thinking, again, I don't need to check anything bigger than 126. So I don't need 144. I know that's, if it's too big, it can't be a big number times a whole number to get a smaller number. So I can start with 121, and I can say is 126 equal to 121 times some whole number. And I can say, all right, if I solve that, whoops, let me go back here. It's going to be, I'm going to divide by 121. So I think we talked about this shortcut here. We're going to take this number, 126, and we're going to divide by these perfect squares until we get a whole number. And again, I recommend start with the big number and work down. Don't start with small numbers and work up. Start with big numbers and work down. So let's see, 126 divided by 121. Pretty sure that's a decimal. 126 divided by 121. Okay, gave me a decimal there. Okay, and again, it's, I don't know. So I'm gonna scoot this over here, and I'm just gonna go down the list. So 121 didn't work. Let's try 100. 126 divided by 100. I know that's 1.26, but use the calculator if you need. Okay, so not 100. How about 81? 126 divided by 81. Decimal. All right, how about 64? 126 divided by 64. 126, we don't get a whole number. 126 divided by 49. Decimal. All right, what's next? 136 divided by 26. 126 divided by 36. Decimal. Nice decimal, but still a decimal. All right, how about divide that by 25? I know we're going to get a decimal there. Okay, how about 16? We're working our way down. Nope. All right, how about divide by 9? Hey, there we go. Finally, we got a whole number there. So, all right, so it's 9, and what did it come out as? 9 times, it'll be 9 times 14. All right, so it's going to be 126 is 9 times 14. All right, so 9 times 14. All right, now we can say, but remember, you're really doing the square root. But the reason we wanted to do 9 times 14 was because we get to use this property at the bottom of the screen that says you can give each number, as long as it's multiplying, you can give each number its own square root, but keep the multiplication. 9, the square root of 9 works out to be exactly 3. I think we saw that in the last one. Square root of 14, you can check, doesn't work out nicely, but this would be it. Our square root of 126 simplifies exactly to 3 times the square root of 14. So the only thing I'm going to do is I'm going to check that. 3 times 14's square root equals 11.224. Okay, the square root of 126 was 11.224, whatever. So feels good, all right? I think I got 4 more examples. We'll try to go through them quickly. Okay, so next example, we're trying to simplify the square root of 132. I've already done the estimate on the calculator. The calculator said the square root of 132 is 11.489, whatever. But if I'm using the perfect squares method to simplify, I want 132 written as one of these perfect square numbers times a whole number. So remember, I don't have to check anything bigger than 132. So I can skip 144, that's bigger. I can start with 121, and I can say, is 132 equal to 121 times some whole number? Let's solve that, see if we get a whole number for x. I'm going to divide by 121. If you've figured out the shortcut by now, you don't have to write this down, but that's our shortcut, we said. It's the number, in this case 132, divided by the perfect squares. So if I do 132 divided by 121, decimal. Okay, let's work down. Divide by 100. 132 divided by 100. I know that's 1.32, decimal. Okay, work our way down. 81, 132 divided by 81 gives me a decimal. 132 divided by 64. I'm pretty sure that's going to be a decimal, but let's find out. Okay, 132 divided by 49. I think that one's a decimal. Indeed, 132 divided by 36. What does that give us? Gives us a decimal. 132 divided by 25. I know that one gives me a decimal. Okay, 132 divided by 16 is a decimal, not a bad decimal, but a decimal. 132 divided by 9 is a decimal. All right, 132 divided by 4, come on. There we go. Okay, so 132 is 4 times 33, and 4 is a perfect square. So we could say 132 is 4 times 33. And then we could say, yeah, but remember you're doing the square root. So the square root of 132 equals the square root of 4 times 33. We can use our property that says you can give each number its own square root because it's multiplication. This does not work if you're doing addition inside the square root. But the square root of 4, you can check out on the calculator. It's exactly 2. Square root of 33 doesn't work out nicely. So this is our simplified answer. The only other thing I'm going to do is I'm going to check on the calculator. 2 times the square root of 33. I'm hoping I get that 11.489. Let's see, 2 times 33's square root is equal to 11.489, whatever. All right, cool. Looks good. Let's do another one. Okay, so now we're doing the square root of 300, trying to, or excuse me, simplify that. Whoops, I got to switch it on the There we go. Now I got it typed out. This the square root of 300. To simplify that, calculator tells me it's approximately 17.320, but I want an exact answer. So again, I'm gonna skip showing you a lot of this, but just the process here. If I'm looking at perfect squares, I don't need to go any higher than 289. So I could start there. So I could say, all right, is 300 equal to 289 times some whole number? I could solve my equation. We've said now the trick is to divide by the perfect squares. This is going to give me a decimal. You can try it out. It's going to be 1 point something. I'm going to skip showing you working down, but I'm going to show you the biggest perfect square we can find. So I skipped showing the process, but it turns out that in my list of perfect squares, 100 is the biggest perfect square. That's a factor of 300. So I'm going to use the 100 here. So remember that it's not really just 300 is 100 times 3. It's the square root of 300 would be the square root of 100 times 3. And we have the property we have at the bottom that says as long as it's multiplying, you can split those numbers up, give them each their own square root. And then if you don't know, it turns out the square root of 100 is exactly 10, no decimal. Square root of 3 doesn't work out nicely, so we'll leave it there. And then the only other thing to do, perhaps, is to check if we do an estimate of 10 times the square root of 3, we hope we get the same estimate as the square root of 300. So 10 times 3's square root is equal to 17.320. Hey, looks good. Okay. Now I do have one more thing to say on this specific example, and that is to be careful, make sure you get the biggest perfect square, because some people might say, hey, you know what, I recognize that 25 is a perfect square factor of 300. If you know how to count by 25s, 25, 50, 75, 100, you can work your way up to 300. So you might say, well, hey, I know that 300 is equal to 25 as a perfect square times, I believe it's 12. And you can say, okay, but we're doing the square root. So it's really the square root of 25 times the square root of 12. And then you can be like, well, square root of 25 comes out to 5. And then square root of 12 doesn't work out nicely. So why isn't 5 square root of 12 our answer? I can even try it out. 5 times 12 square root gives me 17.320. See, it's the same thing. And it's not that we're wrong, but it's just that we haven't simplified completely, because the square root of 12, I don't know if I have good space to fill this in, square root of 12 could simplify. It turns out that that's 2 times the square root of 3. So it's that you could simplify it more. This is why you want to find the biggest perfect square numbers so that you simplify it completely there. So just be careful. That's why I kept working down the list, saying what's the biggest possible number on our perfect squares list. And I worked down from the biggest to the smallest instead of going from the smallest to the biggest. Okay. But let's see. I got I think 2 more examples if we can get through. All right. Our next example here looks a little bit different from our previous 4, but it's 11 times the square root of 375. So we've gotten a lot of answers like this. It's a number outside the square root times a number inside the square root, or times the square root of a number. So when you're doing this on the calculator to get an estimate, just do that. Just be like, it's 11 multiplied by the square root of 375. 11 times the square root. So my calculator gave me an estimate of 213.014. Whoops, I got to change this ink. There we go. Sorry about that. All right, so again, if we're using the perfect squares method, we want to find 375 written down as a perfect square number times a whole number. And we've said, going through our list, we don't have to start with anything bigger. So I would start with 361 and work my way down until I find one of these square numbers that gives me a whole number when I divide. Turns out that it's 25. I'm skipping showing you all that work, but turns out that 25 is the biggest perfect square. That's a factor of 375. So it's, whoops, and I meant to give myself a little bit more space there because we're going to have to bring that 11 in. So I'm going to give myself a little more space. So 375 can be broken down to 25 times 15. But there's a couple other things we're missing right now. First of all, remember, it wasn't just 375, it was the square root. Okay, so the square root of 25 times 15. But then also remember we had that 11. So I go, okay, so let's bring that 11 in. Okay, so it's 11 times all of that. All right. Well, the 11 is just going to hang out for a little bit, but we've got that property that says the square root of a product is the product of square roots. So the 25 and the 15 can get each their own square root. Again, the 11 is just going to hang out, but the square root of 25 is exactly 5. And then the square root of 15 doesn't work out nicely, so we'll just leave it. But now we got one more step to do, and that's to do, hey, 11 times 5 is outside the square root. So this is 55 times the square root of 15 when we do 11 times 5. And then again, the only other thing to check is to just say, hey, when we did the original, we got 213 point whatever. Let's try 55 times 15's square root, and I get 213.014. Okay, looks good. Yeah, so again, as long as you found the biggest perfect square, you shouldn't have to worry about, wait a minute, can I simplify more? We saw that in the last example. Okay, let's do one more. Whoops, I got some wrong. Okay, so last example, we're going to simplify 8 times the square root of 490. I've already done the calculator estimate. I encourage you to do that. 8 times, 8 multiplied by the square root of 490 is a little over 177. So if we're using the perfect squares method, I'm going to focus, the 8 will bring the 8 back later, but I'm going to focus on what's inside the square root, 490. And I'm going to say I want to find 490 as one of these perfect square numbers times a whole number. So again, this is why I had to go up to 23 squared, just to make sure 529 is bigger than 490, but I don't need to check it. 484 is where I would start my search, and I would say is 490 equal to 484 times some number? Is it a whole number? And I can work through that, but I'm going to skip that. Turns out in this case, 49 is the biggest perfect square factor, and it'd be 490 would be 49 times 10. Again, it's a good idea to just make sure you check all the other, we landed on 49, but did you check all the perfect squares between, just in case, like we saw in that other example. All right, so 490 is the perfect square of 49 times 10, but we're doing the square root of 490, so the square root of 49 times 10, but also we have the 8. So I'll bring the rest of that back. Okay. We get this property here. The 8 can stick around, but we got this property about the square root when you're multiplying. 49 can have its own square root. 10 can have its own square root. These perfect square numbers, the square roots work out to whole numbers. Square root of 49 is exactly 7. Square root of 10 doesn't work out. So we'll leave that. The only other thing to do is to multiply 8 times 7. So that's 56. And then square root of 10 just stays like that. Okay. And then to make sure, I guess, to check, if we do 56 times 10's square root, we get 177.087. So yeah, remember, we've got the prime factorization method too. This sometimes might seem like a lot of kind of guess and check work with like which perfect square number, but if you're familiar with it, sometimes smaller numbers you recognize, like, oh, I know 25 is a perfect square factor of that. And then you don't have to do the prime factorization. But this is just one method, so I hope this video helps you, and we'll see you in the next video.